It's kind of funny when you think about it. Time is the one thing we all share, right? But it's also one of the deepest mysteries in the entire universe. We measure it, we feel it passing, but what is it really? So let's dive in, because trust me, the answer is a whole lot stranger than you probably think.
Okay, so first, let's start with something I know you've felt. You've been there, right? 10 minutes stuck in traffic feels like an absolute eternity. But then, 10 minutes doing something you love, and it's gone in a flash. The clock on the wall is ticking away, steady as can be, but the clock inside your head? Oh yeah, it's playing by a totally different set of rules.
And that's the whole thing, isn't it? Our perception of time, what scientists call subjective time, is super flexible. It's not about the clock on the wall, it's all governed by our brains. Things like our attention, our emotions, our memories, they all have the power to bend and warp it. So how does that actually work?
Well, this is our inner clock in action, right here. On one hand, you've got what they call a flow state. You're lost in a great video game or deep in a conversation, and you're so totally absorbed that your brain just stops counting the seconds. And then poof, hours have just vanished. But on the flip side, picture yourself in that waiting room. Your brain is getting zero stimulation, so it just turns inward and becomes painfully aware of every single tick of the clock on the wall.
So, what other things can totally warp our internal stopwatch? Well, a few big ones. First off, novelty. Just think back to when you were a kid. Those summers felt like they lasted forever, right? That's because everything was new, and your brain was creating tons of memories, like little mental bookmarks. As adults, we're stuck in routines, so we make fewer bookmarks, and time just feels like it's flying by. Then there's emotion. Intense fear, for example, can make it feel like time is slowing down because your brain is recording everything in high def. And get this, there's even something called the return trip effect, where the drive home always feels shorter than the drive there, just because the route is familiar. Weird, right?
Okay, so that's the clock inside our heads, kind of squishy and personal. But what about the actual clock of the universe? I mean the big one. For centuries, this whole question was basically a battle between two absolute giants of science who had completely, and I mean completely different ideas about what time is.
First up, you've got Isaac Newton. For him, time was easy. It was absolute, universal. He basically imagined it like a giant cosmic river, flowing forward at the exact same constant speed for everyone, everywhere in the universe. It didn't care if you were on Earth or on Mars, standing still or running a marathon. Time was just this steady, ticking backdrop for reality. And you know what? It makes perfect sense. It feels right.
But then Albert Einstein shows up, and he pretty much just walks in, looks at Newton's perfect, tidy river of time and says, about that. He didn't just tweak the idea, he completely shattered it, proposing that time was something way, way weirder and much more flexible.
So here's the debate. On one side, you have Newton's river, rigid, constant, flowing the same for everybody. But on the other, you have Einstein's trampoline. He imagined that time and space are actually woven together into this four-dimensional fabric he called space-time. And just like a trampoline, this fabric can be bent and warped by heavy objects, like planets, or by moving really, really fast. And this is the mind-blowing part. Your personal experience of time literally depends on where you are in that fabric and how fast you're zipping through it.
And this isn't just some abstract theory, okay? It has some truly wild but absolutely proven consequences. For one, the faster you move through space, the slower time passes for you. That's time dilation. It's the whole idea behind the famous twin paradox, where one twin goes on a space journey and comes back younger than the one who stayed on Earth. Gravity does it too. Time literally ticks slower in a strong gravitational field, like near a planet. And look, this is so real that the GPS satellites orbiting Earth have to constantly adjust their clocks for these effects. If they didn't, your GPS would be useless, off by several miles every single day.
All right, so time isn't a steady river. It's a bendy trampoline. Got it. But that brings up a whole other mystery. You see, on a microscopic level, most of the laws of physics don't care about direction. They work perfectly fine forwards or backwards. A movie of planets orbiting a star would look just as plausible play in reverse. So, if that's true, why does time in our world only ever seem to move forward? Why do we remember the past but not the future?
Well, the best answer we have comes down to one powerful word: entropy. All entropy really is a measure of disorder or randomness. And one of the most unbreakable rules in all of physics, the second law of thermodynamics, says that the total entropy of the universe, the overall messiness, is always increasing. And it's this unstoppable march from order to chaos that seems to give time its arrow. Think about it like this: an egg.
A whole egg is a pretty ordered low entropy thing, right? Now you crack it and scramble it. Suddenly you have a high entropy mess. Now, could all those scrambled bits just randomly bounce around and reform a perfect egg? According to physics, yeah, it's technically not impossible, but it is so unbelievably astronomically improbable that we can safely say it's never ever going to happen. And that right there, that one-way street from a tidy egg to a messy scramble, that's the arrow of time.
Okay, so we've covered a lot. Time is personal. It's relative. It has a direction because of messiness. But now, we have to go one level deeper and ask the ultimate question. After peeling back all these layers, what if time isn't actually real at all?
And look, this isn't just some late-night philosophical question. This is a very real problem that physicists slam into when they try to get their two biggest theories to play nice together. That's Einstein's relativity for big stuff and quantum mechanics for tiny stuff. When they try to build a theory of everything that describes the whole universe, something really weird happens to time.
So there are basically two big ways to think about this. The first is what we all feel intuitively, called presentism, the idea that only the present moment is real and we're moving through time from the past into the future. But relativity strongly suggests a different picture, called eternalism. This is the block universe idea, where the past, the present, and the future all exist simultaneously, just like places in space. In this view, our feeling that time is flowing is just an illusion.
And here's the real kicker. When physicists try to write down the most fundamental equations that describe the entire universe, like something called the Wheeler-DeWitt equation, the variable for t, for time, it just disappears. It's gone. It's not in the equation. This has led some of the smartest people on the planet to think that time might not be a fundamental part of reality at all. Instead, it could be an emergent property, kind of like how wetness isn't a property of a single water molecule, but it emerges when you have a whole bunch of them together.
So that leaves us with this one final, really profound thought to chew on. Are you actually moving through time, or is the universe just a static, timeless place, and the feeling of time moving is just a story that's happening inside you? We don't have the answer yet. It's right there at the edge of what we know. But it really makes you think, doesn't it?